In this video, I am going to discuss one more concept from the plane, which is combined equation of a pair of planes. So, to find the condition that general homogeneous equation of a second degree in x, y, and z, namely ax square plus by square plus cz square plus 2fyz plus 2gzx plus 2hxy equal to 0, may represent a pair of planes, and to find the angle between them, also to find the condition for perpendicularity of these planes. These are the things we are going to discuss in this video. This is our equation. So let me just, this is the, sorry, this is the equation we are going to handle, and this is a second degree homogeneous equation, as you can see, uh, and we will see what is the condition for this second degree homogeneous equation to represent a pair of planes, and it is if it represent a pair of planes, how to find the angle between those planes, and what is the condition for those planes to be perpendicular. That is what we are going to discuss in this video. So okay, so let's start with the equation itself. So this is our equation, second degree homogeneous equation. So first thing you can notice is there is no constant term in this equation. So if there was a constant term, this would not have been a homogeneous equation. So let me just, this is our equation. So suppose, let's think about two planes, L1x plus M1y plus N1z equal to 0, and L2x plus M2y plus N2z equal to 0. Suppose these two planes, the product of these two planes represent this equation. So if that is the case, what does that mean? That means ax plus by square plus cz square plus 2fyz plus 2gzx plus 2hxy is equal to L1x plus M1y plus N1z into L2x plus M2y plus N2z. So now we can just compare the coefficients of x square, y square, z square, and get few conditions if this is the case. So as you can see, L1 L2 L1 into L2, which is the coefficient of x square, L1 into L2 will be equal to a. Similarly, so if I want, let me just, I will just note down what I'm hearing. So L1 L2 equal to a, M1 M2, which is the coefficient of y square, is equal to b, and N1 N2 equal to c, so which is the coefficient of z z square. Now what is the coefficient of y z? C, 2f will be, f is equal to coefficient of y z. So there are two terms, y into z, which is m1 into n2, m1 n2 plus, and this z into, so n1 m2 n1 m2 n1. 2f will be equal to this, and 2g is the coefficient of zx. So if you see, zx will be n1 L2, so n1 L2 plus, similarly zx, we took 1 L2. So next is n2 L1 L1, and 2h we get as the coefficient of xy plus. So as you can see, there are some symmetry going around here. So m1 n2 plus m2 n1 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 n n1 l2 plus n2 l1. So that kind of symmetric situation is going on, and we will be using that. Now we need for the condition, we first need to eliminate L1 M1 and N1 and L2 M2 N2 from all these equations. So for that, use the, we know that L1, what is L1 M1 N1 and L2 M2 N2, these are the direction ratios of the normal. So from that, take one L2 N2 and 0 0 0. This if you this is a simple easy method to solve our equation. I will just explain how. This is a zero determinant. Since we have this 0 column, 0 0 0 column, the determinant of this will be 0. So that into m2 n2 and l1 m1 1 and 0 0 0. You can say that this is equal to 0, right? This is two determinants with 0 columns that will be that will give the result as 0. You see, if you know how to multiply two determinants, so it will be like, first we'll just multiply and find out what uh, each element represent. So first element will be obtained by multiplying L1 L2 plus L2 L1 plus 0 into 0. So that will give L1 L2 plus L2 L1 because 2 L1 L2. This will give 2 L1 L. Similarly, second will be given by L1 M2 plus L2 M1 plus 0 into 0. So L1 M2 and L2 M1. Write that L1 M2 plus L2 M1. And third one will be given by L1 N2 plus L2 N1 plus 0 into 0. So L1 N2 plus L2 N1. So this is the first row of the product. This is the case. So similarly, if you expand second one, L2 M1, L2 M1, L1 2, 0 into 0. Now second M1 M2 plus M2 M1 to 0 into 0. So 2 M1 plus M1. And third one N1 2 L1. Similarly, N1 M2 plus N2 N1. So if this product of these two determinant is given by this, and since this is equal to 0, this is also equal to 0. Now and of L1 what we got here in this determinant. So if you see L1 L2 is A, M1 M2 is B, and N1 N2 is C, we can use that here. Then we get 2A, this become 2B, and this become 2. And L1 M2 plus L2 M1. What is that? L1 M2 1 M2 plus L2 M 2H. This is L1 N2 plus L2 N1, L1 N2 plus N1 L. This is L2 M1 plus L1 M2 same as 2H, and M1 N2 plus M2 N1. So M1 N2 plus M2 N1 is 2F. N1 L2 plus L2 L1 same as this. 1 N2 1 plus 2G. I wrote it as 2H. 2G. So the same as here. So G, and this is 2F equal to 0. Or we can write this simply as, if you take 2 out and cancel it out, we get A H H B F F is equal to 0. So this is the condition. If this is the condition, if this equation, this homogeneous equation, is a product of these two planes. So if we can, if we check this determinant and if we find it to be 0, then we can say that it represents the product of two planes, and the direction ratios of normals of the plane will satisfy all these equations. So if you open it up, we can simply see that this is nothing but, if you apply the formula and open it up, we will get ABC plus 2FGH minus AF square G square minus CH square equal to 0. So if you open this determinant, you will get this equation. So this is if you want, you can remember this equation, or if you just this is pretty symmetric, right? A B C H H G G F F. So this determinant will be easier to remember, but if you open up the determinant, you will get this form. So this is the formula that we need to check whether to see whether the given homogeneous second degree equation represent the product of two planes. So that is the required condition. So that is done. Now next is finding the angle between the planes. So finding the angle between the planes. So we have our planes as L1x plus M1y plus N1z and L2x plus M2y plus N2z. In such condition, so I will just write equal to 0, 2x plus M2y plus N2z equal to 0. This is the two planes we are handling. So how do we find the angle? So the tan theta, instead of, we'll see what is tan theta. Tan theta for such planes is given by sigma m1 n2 minus m2 n1 the whole square by L1 L2 plus m1 m2 plus n1 n2 into so uh, just a reminder, if you want, this is the tan theta, you can simplify the equation. I'll just, before that, if you want to check the perpendicularity, we have discussed that before. Cos theta is L1 L2 plus M1 M2 plus N1 N2. So N1 N, and when the planes are perpendicular, cos theta will be equal to 0, and this will be equal to 0 if perpendicular. So in that condition, we got L1 L2 as A and M1 M2 as B, N1 N2 as C will be equal to A plus B plus C will be 0. That is, from where did we get that? This from this L1 L2 is A, M1 M2 is B, and N1 N2 B, and A plus B plus C equal to 0. In other words, the coefficient of x square, y square, z square, if you sum it up, if you get 0, and if this homogeneous equation represent the product of two planes, then those planes will be perpendicular. We can get that from here itself. So this is the equation of tan theta, and the reason why I have written up this is this equation can be simplified further, and we can use that to find the theta. So how can we simplify this? If you see m1 n2 minus m2 n, this equation can be written as sigma m1 n2 plus m2 n1 the whole square minus 4 m1 m2 n1 n2. So instead of this, we can write, so if you write it in this manner, so if we know that for there is a sigma here, don't forget about that. The sigma m1 n2 plus m2 n1 is nothing but, we got m1 n2 plus m2 n1 is nothing but 2f. So we can see this nothing but 2f the whole square minus m1 m2 is 4, m1 m2 we know it is B, and n1 n2 is C, so 4bc. So this reduces to this. Now since this sigma, we can this is a symmetric equation, so we can expand this as something like this: 2f square minus 4bc plus 2f the whole square. So sorry, so 4f square minus 4bc, or 4g square. When f comes, it is bc, and when g comes, this becomes ca. 4ca plus 4h square. When f comes, it is bc, when g comes, it is ca, and when h comes, it is ab, 4ab minus 4ab. Or this can be written as total here. So it will be the whole square. This will and there is a root here, so whole by 1 by 2 is there. So okay, but if we write that, we'll have to write the denominator also. So I'll just I'm simplifying this numerator part, so we'll use that, and from this we can write tan theta is, what is tan theta? Tan theta is equal to 2 4. There is a common 4 here, and since there is a root here, taking 4 out of the root, we get 2, and root of f square plus g square plus h square minus bc minus ca minus ab by what is L1 L2 a, m1 m2 is b, and n1 n2 is c. Get a plus. So this is tan theta, and theta is nothing but tan inverse of this. So we can use this formula also. And condition of perpendicularity can be found out from this formula itself. What is the when tan theta is equal to 90 degree, tan theta is equal to infinity. That means this term will be 0, or a plus b plus c is equal to 0. This is the same condition we got here. So a plus b plus c is equal to 0. So this is the condition for perpendicularity. We can derive it from here, or we can see directly take it from cos theta is equal to 0. These are the concepts that we will be using to solve some questions ahead. So I hope you understood it. If there is any doubt, please do comment under the video. So we have a homogeneous second degree equation, and we assumed that that to be a product of two planes, and we compared the coefficient and extracted this in terms of a, b, c, f, g, h, and now we wrote it this as two product of determinants, zero value determinants, for simplifying the equations. For eliminating L1, M1, N2, and substituting everything with A, B, C, we did this step. That is, this is something that if you to derive this is an important step. Not that very intuitive. You have to know it. So, and if you open up the determinant using the product of rules for the product of two determinants, you will get this. And this, if you once you get this all the terms can be substituted into a, b, c, and f, g, h. So we substituted everything to a, b, c, f, g, h using this and these equations. So I'll just call this I didn't name anything. Call this 3. We substituted and we found out the condition required for our homogeneous equation to be product of two planes. So, and we found out the condition, the theta, the finding how we can find the angle between the planes, and we also found out the condition for perpendicularity. So these are the concepts. You can pause and note down if you want. So yeah, we'll solve some problems using these concepts next. Thank you.